Acid or green? Green.
That's great.
Green.
Just one more minute here.
We got one.
Smile.
I'll be right back.
All right, ladies and gentlemen, if you get your attention back up to the front for organ transplantation group, please give them a warm welcome.
My name is Frank. This is Annie, Sydney, I'm the worst. Michael, we are talking about organ transplantation is something that many people know about, but not many people know much about, and the importance of it. To begin with, a simple definition of organ transplantation is taking a working organ and replacing it with a non-working organ with a working organ. To do this, many times it's used with donors. Our research is going to be using stem cells to develop. Our research is going to be using stem cells to develop ways to grow our own organs to replace many organs instead of just relying on donors.
There are some issues that have developed since the practice of organ transplantation has become more common. There are a lot of people who require new organs, but there's a shortage of organs and not enough for each person who needs one. Currently, there are more than 124,000 people in the United States on the waiting list for an organ, and another name is added to this list about every 12 minutes. There are not nearly enough donors to meet this need. In 2014, there were a total of 14,412 donors for over 123,000 people who needed an organ. On average, 21 people die every day waiting for an organ that they could not receive. If there was a way to increase the amount of organs available for transplant, this would drastically increase the amount of people who are able to receive the life-saving transplant that they need. Finding a way to create organs with stem cells could be a solution that would drastically decrease the amount of people on the waiting list and increase the amount of lives saved.
Currently, some of the countries in Europe allow embryonic stem cell research under certain regulations, and some of the other half of the countries completely ban it. The U.S. used to be divided like this until in 2009, President Obama legalized the research of embryonic stem cells in all of the U.S. This issue is obviously controversial because of the differences in the opinions in the places that there used to be and still are these differences. The reason it's controversial is because the embryos are taken from humans, and some people believe that this is unjust. When life begins is an ambiguous question, and some people believe it's as soon as the embryo is formed, and others believe that it's not until the heart starts beating. Because of this, some people believe it's not okay to take an embryo from a person and destroy it during the research of it because they believe that it's qualified as murder.
Okay, so our proposal is to research further in stem cells to create organs. we, as Michael said before, that they are controversial, so we're trying to find a solution to the long waiting list and the controversy behind these cells. By furthering stem cell research and creating organs, the donor can match the organs, there won't be as high a rejection rate. By doing this, we we can create organs to replace the failing organs, and the rejection will not be as high.
Okay, for our budget for this project, for the research of stem cells, we would be using the money to hire 4 part-time researchers, each with an annual salary of $40,000 a year, including an office manager with a salary of also $40,000 a year. Manage stuff like monetary exchange, documentation of research. And then the research materials will cost $25,000 a year. And then, and then the lab will also cost $25,000 a year to rent for 1 year. As you can see in this chart, most of the budget is being saved towards the research. We decided to go part-time researchers because we wanted to go for more of a divide and conquer strategy. And to maximize the amount of funding towards the research itself, an ideal place would be to have the lab would be either places like Georgia or South Carolina, where they have mild climates and it would decrease utility costs. With where this is going in the future, not everything can be done necessarily in 1 year, but the hardest part of getting work done is actually getting it started. So when we start this research right here, after our year, it might amount to something.
Organ transplantation impacts people all over the world, and with an increase in stem cell research, this number will continue to rise. The immediate effects of being able to generate organs that have a specific purpose include less rejection rates, less ethical issues in the field, and also a longer lifespan for humanity in general. Behind me is a chart that distributes the expenditures that the grant will be used for. 80% of this in total is for human resources. This is due to the fact that we would like to increase the amount of employment we have to increase our efficiency and also our output. Lastly, our goal is to create viable organs that we can transplant into people. This would solve most problems in the organ transplantation world that involve around the economic and financial side and also the biological side. We would like to thank Vertex for listening to our proposal.
So at the end of the year, what do you guys will constitute success? Like at the end, because you said there's only so much you can get done within a year of research with a small team. So for you guys, at the end of the year, this means we succeeded, this means we failed. How are you going to measure success with this?
Well, if we have like a footway into the door of creating organs with the stem cells that we can use, that would constitute success.
Currently in labs, researchers are already starting to do labs with like rats and stuff. So they can take rats and then like right here, this right here is these are organs from rats. And so they've started to try to cultivate them and try to reproduce them. And so we would like to sort of go like break away from this, but start with human organs.
For stem cells, they come out when the baby's born, right?
No, it's
Like what are stem cells exactly?
Stem cells, there are multiple types of stem cells. How do they? And the most common one that people know about is the embryonic stem cell, which is the very, very first cell that you are. It's with sperm and egg combined. That is the very first stem cell. And later on as you progress, certain stem cells, they lose what they can. That's why embryonic stem cells, they can become permanent. Later on, there are certain stem cells that branch off and we become bone, muscle tissue, heart tissue, etc.
Okay, and so then, so you get your embryonic stem cell, and then, like, you have like a new patient, and you need like, I don't know, like a liver or something like that. And so you have your embryonic stem cell, and then you grow that into a liver.
That depends on, so if that patient needs a liver, our research is going to figure out how to make the DNA, like your cell, figure out which section of its thousands and thousands and thousands, just base pairs, just everything. Our research is going to try to make it so we know how to initiate that section to start developing, liver, lung, heart, whatever it needs.
Just a quick interrupt. So you, for your research, you'll be using the embryonic stem cell, yes?
That's correct.
So once you harvest that, that's the end of that possibility of that becoming a child, right?
Our cell, it doesn't have a nucleus. They're in vitro fertilization, so they're made in labs. They take an adult stem cell nucleus and they put it in.
Can you elaborate on what that means?
Like
What you just said, I'm not
Embryonic stem cells are not embryonic.
It's adult stem cells.
Okay.
And then another way is they take stem cells from umbilical cords when babies are born. You have the expecting parents have the option of donating them, discarding them, or saving them.
Thank you.